regression is also called a least squares regression line. Oh, that's the fancy term. Okay, so it's informally a single straight line that best fits through the scatter plot. An example of the scatter plot with regression line is shown below. So we have techniques for doing it. So if you ever get in the world, if you ever get into the world of statistics, they will often have the equation look like this, where this becomes the slope. This is called y hat, because I got a hat on it. All right, so if you go and you graph this type of stuff, in the world of statistics, they have slope-intercept form that goes backwards. My friends, only thing I would say is to remember is whatever the x value is, whatever's in front of x is going to be the slope, no matter what the order. I mean, we learned in Algebra 1 to have it like this. So why does statistics go to make it backwards? I don't know. But I do know that a lot of times with statistics, you start seeing white hat. That means you're dealing with a regression line. Just to confuse you all, they will say the line of least squares regression or something like that. And you're like, what does that mean? Line of best fit. Why don't you just say that? I don't know. It's just they're mean and they pick on people. Okay, so on Desmos, Desmos just will do it like this with us. We've learned that if we use y1 tilde mx1 plus b, the tilde, tilda, I think that's how you spell it. That's how Stirrup spells it, at least. It's like, no, there's numbers in there and stuff. All right. So tilde is the operator on Desmos to allow Desmos to know, hey, I need to find an equation from the data that's given. You will use tilde anytime you find any type of equation on Desmos. And that's just how they go. Tilde does indeed become the equal sign as far as an equation goes. If I asked you for the equation, you gave me y tilde mx plus b, that's totally fine. I'm not too concerned about it. I know you know what you're talking about. So they're just trying to build from the equation or the data above that there is an a value of roughly 1.56 and a slope of 0.06 roughly. So they have the equation kind of written out of order from what Algebra 1 and Algebra 2 normally had done. And then it says the little caret means predicted. So when you start seeing this caret up here, this is what we use for predictions. And I'm probably going to spoil things you learned in science, so don't tell your science too loudly. If you do, I'm Mr. Johnson, and confuse them. So talks about in algebra, use y equals mx plus b. We talked about that. The slope is always attached to the x. The y-intercept is the constant. That's the number that doesn't have a letter associated with it. Okay, so y hat is for predictions, and we go from there. And so this is where science and math don't match up, but we do it regardless. Okay? All right. So the purpose of making an equation is then you can do something called a prediction. So if I had data, and I'm going to kind of just make these points really kind of big. Okay. So if we had a line of best fit, and let's say we use Desmos to find this line of best fit, and so we find that this is maybe y equals 2/3 x plus 5. It's not even plus 5. It'd be like -1 or something like that. If we use the world of statistics, we would have it like this. And we put a hat on it. Now, this is where science and math start splitting apart. And I'm sorry, you didn't know there was going to be a divorce that took place, but it's taken place today. All right. So if I make a prediction, within my data. Okay, so here's my data. Okay, within that, come on. Within this yellow region, all of my data points exist. Do you feel comfortable with that statement? Okay, so if you had some x values down here, what you can do is you can basically say, oh, if I chose this point here and I draw this line straight up and then I draw this line straight over, let's pretend Stirrup knows how to make a rectangle, we can find this y value. Okay, being it happens inside your data, this is called interpolation because it's inside your data. Okay, interpolation is actually the only acceptable way of using data to make predictions. Unfortunately, people who knew a little bit about math might have taken a x value way out here, and they're like, oh, because my line's a straight line, it keeps going and going and going forever. They actually think, oh, I can bring this over and I can find this y value, and this is outside of our data. And if it's outside the data, it is called extrapolation. Now, friends, you got to be very cautious about this. Statistics is a big math, but it's a big math that people are like, oh, it's not that important. I learned how to find mean, median, and mode and range, and I know everything about statistics. Unfortunately, you don't. Okay, you will. You'll learn more, which is great, but extrapolation is not an acceptable thing to do. But every business does it, and science does it. You collect data from your lab, you create your line of best fit, and you make a prediction. If your prediction's outside, bless you. If it's outside of your data, it's called extrapolation. It is not statistically acceptable to do it, but we still continue to do it because the reason we do extrapolation is sometimes the only data we have forms the only model we have, so we make a prediction based on it. Now, that ties back into what we had been doing. Yeah?
So it's just if it's outside the range for your actual y value?
If it's outside of your data points. Okay? So if you make a prediction and it's extrapolation, this is where, remember the safe words we've been talking about? Our data shows this, so we may be able to conclude, we may be able to say. Using the safe words is how they start getting away with it, which is fine, okay? It's when you start using the hard words, the words that are going to get you in trouble, the ones that mean you have to be held accountable, is where we have to be very cautious. So, I'm sure you all have taken some sort of science class that you've written down data, you try and draw in your table, you're like, how should we label the x-axis, y-axis, and you go through the whole thing, and then you get your paper back, and the teacher's like, you didn't put a title on it, and like, dude, the title's at the top of the page. So why are you docking me not having a title? If the title's at the top of the page, I didn't title my graph. And it's one of those nitpicky things that people do. Just believe me, especially now with all of the ChatGPT and the AI stuff, there's a lot of times that you could actually put in your data into a report, and ChatGPT is going to come up with a very good report for you. And the nice thing is ChatGPT continues to get smarter and smarter. Okay? Should you use ChatGPT? Yeah, you should. Okay? Now, should you turn ChatGPT in as your own? If you can get away with it, I'd say go for it. If it's going to get you in trouble for, using some sort of outside source, don't do it. Yeah, I will tell you, at University of Colorado, my wife does, the Turnitin stuff for lab reports, just like you guys would do Turnitin.com or whatever it is. But I don't think Cherry Creek schools pays for this service while CU does. So ChatGPT is tied to the internet. So is Turnitin.com. So as soon as you have ChatGPT write something for you, even if you've hit clear or delete or close out of the program, your information from ChatGPT is now out someplace living. It exists. So here's the big kicker. This is what you need to know, especially as you're going to college, because let me ask you this without getting anybody in trouble. Has anyone ever turned something in using ChatGPT as your own? Okay, we got some honest people. Okay? Yeah, if you got to get away with it, great. But I will just need to warn you that at the next level in colleges, universities, they pay for the next level of Turnitin.com, which means Turnitin.com goes through and it looks for, do you have any similarities to any written books or any written papers or anything on the internet? Anything on the internet now is actually anything that you've ever done on ChatGPT. Okay? I've used ChatGPT to say, how would something be stated? And then I turn it back into my own, and they're not sure if that's even acceptable at that because I used AI to formulate my thoughts. So I put in the initial, I got this and this and this and this. You know, write me a 5-paragraph essay on this. ChatGPT does. You can even change that 5-paragraph essay to, could you make this a college level 5-paragraph essay? It's going to change the, you could say, I want it as a first grade 5-paragraph essay. You know, you can change the level of it, but as soon as you put something on ChatGPT, it now lives somewhere on the internet. And the next version of Turnitin.com, the higher paid version, if someone turns something in using ChatGPT, it goes to the higher level thing on the Turnitin.com, and there's time, it'll come back. It'll say, you know, 98% of this paper was AI generated, okay, because it lives somewhere. Now, I've always been the person saying, well, what's the probability that somebody wrote the exact same paper as me in the exact same words? Well, I mean, there's only 8 billion people in the world. I guess it is statistically sound if you could say you could have written the exact same thing that ChatGPT would have. But you just got to be cautious. You got to be real cautious on how you do it. So I don't want to see any of you get in trouble for it. I mean, it's like definitely use AI to clean up something, formulate your thoughts, and then create your own paper based on that. That's a much more interesting way to do it. But extrapolation itself, when you deal with it, it becomes or not acceptable in the world of statistics, meaning you can't claim ownership. But if you do an extrapolation prediction, you could say, this was our data model. By using extrapolation, we show this to be the trend. This may indicate this event could take place. Okay, now, are data models used throughout everyday life? Have any of you ever checked the weather?
Sure.
Every one of you, I bet you, well, what's the temperature going to be today? Oh, it's going to be 64. Awesome. Okay? That is an extrapolation. Okay? The computers for your weather, your computers for your weather people, you know, you're watching, you know, the local news and you see the weather and you're like, oh, okay, that's weather. These are all predictions based on extrapolation. Our data is showing this, and in all of these other models, when the data shows this, it predicts this as a temperature. Is it very possible that you might look at a weather report going, dude, it didn't say it was supposed to rain today, and all of a sudden it's raining? And I'd say that does happen, okay? So extrapolation is a way that we could say we could make predictions, but those predictions are from extrapolated data. And so protect you, because you can't say this is the conclusion based on this. It just says, as my model has shown this, my data has given me this, by doing an extrapolation, something that's outside of my data set, we could say this. Now, interpolation is simple. Okay, it's inside of our data. Okay, it's much more acceptable, and you can get away with interpolation, saying my data showed this, my line of best fit showed this, my correlation showed this. Bless you. My prediction by interpolation, so within your data set, shows this. That's very acceptable because, one, the events have already taken place for you to have collected the data. The events that are on extrapolation, you didn't collect enough data to get far enough out to it, or your data didn't go far enough out yet. Now, here's the thing, and it's on everybody's mind, and you guys have been raised this way, and I don't want you to boycott me because I say it, but I'm just going to say this. We have something called climate change. Okay? What was climate change known as, 10 years ago? Global warming. Okay? When I was in elementary school, I still remember this. And the reason I remember this so vividly is they had this Salt River Project, which was the energy company, the electricity company in the state of Arizona, put out a packet for 4th grade. And the packet was basically, how can you save energy? Be an energy sleuth. Okay? And so it had us go and do specific things where we had to go out and look at the meter at a certain time of the day one day and a meter another time and talk about that. We brought it back to class. But I remember I did this whole packet. I remember I turned it into my teacher, and my teacher said, held me from going out to recess because, like, Chris, you didn't turn in your data packet. And I did. So I swear, I mean, I might be a forgetful, meat-headed little kid when I was a kid, but I do remember turning that packet in, and I remember Mrs. Patterson saying I did not turn it in, and therefore I got a 0. And I was like, but I turned it in. She goes, no, you didn't. And I'm like I was ticked. I mean, I had no proof that I turned it in, but I knew in my mind, I remember walking up to her desk and put it in the same basket everyone else did. I'm pretty sure if she had lost it, it was probably one of the kids in my class probably swiped mine because they thought I was a big jerk because, I spit on them at recess the day before or something. I don't know, which is very possible. Okay, so, on the next page, you have those 2 different data sets. You have one that you have data that's very tightly knit together. You have the data that's this, and then you have the data that's kind of all over the place, but yet they have a line of best fit for both of them, which is great. Okay, obviously predictions here, if you had a y-hat prediction here, it's more acceptable because our R value is very close to 1. On this one, our prediction is not as reliable, even if we interpolate it, because our R value is not 1. Okay? So that's basically how you look at it, because you're getting more information on, do I have acceptable data? Do I do acceptable data collection? Does this fit to our stuff? And that's great. So they call this figure A. They call this figure B. So they say that in figure A, data points all huddled together in a very tight linear fashion. The regression equation fits the data very well. There are very few data points that stray away from the regression line. The regression equation makes good for predictions of data. Figure B says that the scatter plot shows weak positive association. The regression line models the shape of the data, but there are many points that wander away from the scatter plot. The regression equation will not make very good predictions for this data, but the equation will still be better than a random guess. Okay? So if the relationship between the explanatory and the response, remember the explanatory is the X and the response is the Y. Okay, and I remember this because explanatory has the letter X in it, so it goes with the X equation. I kid you not, silly little mnemonics that I've used in life have helped me with stuff. So the relationship between the explanatory and response variables is weak. The equation will not make good predictions. The relationship is strong. The equation will make much better predictions. As such, correlation R is generally, but not always, a good way to measure the quality of predictions made by the regression. So on the last quiz, we talked about the R value was important, and it still is important. We are going to learn more and more information as we progress with data to figure out what are the clues that make our data good, and then whatever makes it good, what gives me my prediction equation, my y-hat equation. Can I make predictions based on good data? Sure. Can I make predictions on bad data? Sure. So right now, all we know is R seems to be a good indicator if our data is good or bad. Okay, we're going to learn as we progress further in the class how much data should we have. You know, is 10,000 pieces of data better than 12 pieces of data? Absolutely. Is 30 pieces of data better than 31 pieces of data? You know, say the more data, the better. Okay. So the last thing we talk about on the page, and you can show your science teacher this, and they're like, oh, that's not true. He doesn't know what he's talking about. He's just a crazy old dude, which is probably true. It says one other caution in order. Extrapolation is not trusted. Okay? It's when you are making a prediction that is way outside your data based on your linear equation, it's not to be trusted. Extrapolation is an attempt to predict an X value that is beyond the scope of the data set used to create our linear regression model. It is higher or lower than all the X values in the data set, so it's beyond your points. Okay? An example in A, trying to predict a value of 2.0 would be extrapolation because there are no X values higher in the scatter plot. Okay, again, extrapolation is not to be trusted, but it becomes, we have a model. Can we try and determine what we might think might happen? And the answer is yes, and I used a safe word saying what might happen. Okay, again, it's not exact, but it's like, hey, we're seeing these events taking over play. We've collected this data. We have an explanatory. We have a response. We plotted all of our data. We have a good R value. This is fantastic. Life is good. There might be evidence that could suggest things outside of our data set would still fall along that line of best fit, which is great, but be very cautious when you put it out there. And unfortunately, ever since statistics has been introduced thousands or hundreds of years ago, who knows when statistics really came around? I don't know the history of it all. But we've been using statistics, we've been using data to try and make predictions. Okay? There's always the person that will say, hey, I got a system for how the stock market works. And you're like, oh, okay. Yeah, this is what I do. I look at whatever stock was down for the past 3 days. On the fourth day, I invest in it, and it goes up. And you're like, have you made money? Yeah. Well, why did you drive a Ford Festiva that's a 1982 that only one of the cylinders works? Okay. It's the same thing with in Vegas. Vegas is all bet. You know, you're betting on, you are playing a game. You hope to make the prediction the correct way. You are gambling your money because you're predicting that something could take place. Are there ways to beat the house in Vegas? Yeah. Yeah, you can count cards. As long as you don't change your bet to a higher amount, you're okay counting cards. Okay? It's a legitimate thing. I mean, anytime I play blackjack, I'm counting cards. If you up your bet, and I'm not saying you go from a $5 bet to a $10 bet, I'm talking you doing the $5 bet and all of a sudden you do a $5,000 bet. So their casino is also counting the cards. One of the cameras is focusing on the cards that are on the table. It's doing its own count based on the 3 or 4 or 10 different models that it has, and it shows a prediction. And then the same camera is watching the chips, and it's seeing any trends that are taking place with the person. Person keeps betting $5, whether it's at a plus 16 or it's at a plus 3. Casino doesn't care. It's when it's at the plus 16 that your $5 became a huge bet. Okay? That if it's at a plus 14, 15, 16, 17, or 18, that's where, and you're like, how do you get these numbers? There's many ways of counting cards. An easy way of counting cards, as long as the shuffle hasn't taken place, you can keep the count. Doesn't matter if there's, a single deck of cards or 10 decks of cards in the boot. If you count cards, if you stop at a plus 16, 17, 18, 19, or basically a 15 to 18. If you stop at that, it resets at 18, goes back to 1. You can improve your bet, okay? Or you can improve the odds that you're going to win. So there's been times I've been counting cards going, oh, sweet, I know I'm going to win this next hand because it's in my favor. I don't change my bet because, one, I don't want to get boycotted from the casinos. That's no fun. But it's always kind of fun going, oh, sweet, I'm going to know my bet. Now, there's been times I've been sitting at the table and I'll watch the person sitting next to me and they'll go from a $5 to a $1,000 bet. And I'm thinking to myself, I'm at a +4. And sure enough, that person will lose. Yeah, the casino doesn't care if you're improving your bet, as long as you're not in that plus, that higher range of 15 to 18 or 14 to 18 or anything like that. And how do you count cards? One way of doing it, it's very simple. Face cards, Jack, Queen, King, and 10s are worth 0. Okay? Cards that are from 2 to 9 are worth 1. Aces are worth 2. If you count all the cards on the table, and at the next deal, if you stop counting, basically you're like, oh, there's 2, there's 3, there's 4. Basically it works like this. I'll show it on the screen up here. I have an Abidex of cards. Just for occasions like this. Game of blackjack. What are you trying to get to? 21? Okay, good. So you know that. All right. Sorry, I had to use this. All right. In the game of blackjack. Okay. So if I deal all the cards up, dealer keeps 1 down, has 1 up. So these cards are coming up. Let's say I have. Oh, sorry. So you don't see the dealer's card yet. Okay? We count these cards right now. I'm sitting at a +1. Agree? Yes. Face cards worth nothing. Cards that are 2 through 9 are worth 1. Okay? You get a second card. I was at a +1. Oops, sorry. I'm at a +2, +3, +4. Dealer will show their next card. I'm at a +5. Sitting at +5. Don't improve your bet. Okay? Now as you're sitting there, you're like, oh, dealer's showing a 5 in the game of blackjack. All of the odds players would tell you it doesn't matter what you have sitting in front of you, dealer's showing a 5 because you're assuming a face card's down. Okay? So no one sitting at the table should take a card. Okay? You're always going to get the idiot that takes a card. Okay? So once everything's done, dealer will flip their other card. Okay, so they're showing a 16, an ace, and a 5. Okay? So you have to know which table you're working on. It'll say dealer has to hit on soft 17. Okay? Means you don't have an ace involved. Okay? Ready? What's my count on the table? I got 1, 2, 3, 4, 5, 6, 7. I'm at a +7. Dealer has to take a card. Now we're at a +8. Okay? Should I improve my bet? No. Dealer actually is showing at 13. So dealer take another card. 13, that's a 0. What am I at? Still a +8? Don't improve the bet. I'm not reshuffling. I'm at a +8. Do not improve your bet. Boom, come back around the table. Trying to keep them close so you can see them. All right, I'm at a +8. +9, +10, +11. Agree? +12, +13, +14. Dealer flips over. Okay. No one took a thing because they saw a 9. Actually, what would probably happen? No, I don't want to do that. So I'm at a +13. Don't change your bet. Don't change your bet. Okay? Okay. 13, 14, 15, 16, 17, 18, right? So I'm at a plus 18 sitting on the table. Okay, now it's back to plus 1. Plus 2. Plus 4. Okay? Person sitting at a 15, 12, 8. 18. This person will probably take a card. Doesn't count. Okay? They're at 18. So let's say no one else bets. Okay, so what are we at on our count? So let's say we're at a plus. Let's say we're at a plus 16. Just going with it. Plus 16. Everyone should have improved their bet. Okay. So right now, regardless, because if we were at a plus 18, regardless, no one should take a card. Dealer showing a 13. Dealer has a very good probability that that's a face card, and they're going to have to take another card, and that's another face card behind it. So if we were at a plus 16 here, oh, they're at a 7. We're at a plus 17. Okay, we're at plus 18. Man, we're at our ideal thing. No one's getting any more cards. Dealer's sitting there showing, what are they showing? 12. 22 bust. You just improved your bet on this. Winner, 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 winner. Chicken dinner. There you guys go. You now know how to beat the house.
Thank you so much for that information.
You guys come back and see me in 10 years. Guess what, Stuart? What's that? I'm in the black book for Vegas. What'd you do? The way you taught us how to gamble, I was winning all this money. Okay? But basically, counting cards is also extrapolation. Counting cards is also extrapolation. You're making a prediction based on an outside piece of data. Okay? So, your assignment that you can take a look at for the next couple of minutes is going to be 2-5. 2-4, thank you. So 2-4 is what you can take a look at and play with and take a look at, learn how to gamble with. Most